Now we're going to look at the most special of all the parallelograms, and that is the square. So a square is a parallelogram where all angles are right angles and all sides are congruent. That means it gets to live in both the rectangle group and the rhombus group at the same time. So because a square is both a rhombus and a rectangle, it has the properties of both, namely, the diagonals are congruent, just like rectangles. Diagonals are perpendicular bisectors, just like the rhombus. And the diagonals are angle bisectors, just like the rhombus. So here we're going to take a look. You might end up trying to prove or show something is a square or some type of parallelogram just using the coordinates of the shape. So I've got the vertices are P, Q, R, and S, and I want to show that it is a square. So let's start by finding if these are diagonal, perpendicular bisectors of each other. Do the diagonals bisect each other? So my midpoint for PR is 3/2 for the x-coordinate, and for QS, it's also 3/2. So that's the same x-coordinate for both. That's a good sign. I'll do the y-coordinate for PR, -5/2. And my y-coordinate for QS is -5/2. So when I do P to R, the midpoint's the same as Q to S. So the diagonals do bisect each other since they share the same midpoint. Are they perpendicular? So let's find the slope. PR, the slope for that one is -5/11 because -5 minus 0 over 7 minus -4. The slope of QS is -8 minus 3 all over -1 minus 4, or -11 over -5. These two end up being positive. So I can change that to a plus. And so I have -5/11 for one slope and 11/5 for the other. They're definitely perpendicular. Okay, so that tells me that since the diagonals are perpendicular bisectors, PQRS is definitely a rhombus. Now I'm going to check and see if it's a rectangle. How would I know? Well, rectangles have congruent diagonals. So I can just find the length of PR, and it's 7 minus -4 squared plus -5 minus 0 squared, which ends up being 11 squared plus -5 squared. 121 plus 25. Don't forget that a negative squared is positive. And I get square root of 146. I don't really need a decimal. This is good enough for me to compare. Now let's find the length of QS using the distance formula. I did -1 minus 4 squared for the x-coordinate, x distance, -8 minus 3 squared, and I end up getting -5 squared plus -11 squared, which is still 25 plus 121. Or square root of 146. So the diagonals are congruent, so it's also a rectangle. Since it's and that means it's a square because it's a rectangle and a rhombus at the same time. So for further reflection, why is a square considered to be both a rectangle and a rhombus? And what are some of the different ways you can show that coordinates make a square? The way I did it is I just decided to use the two diagonals because that's kind of what we're focusing on in this lesson. I could have also looked at the lengths of each of the sides and made sure they were all the same and made sure they were all perpendicular. The advantage to using the diagonals is I'm only comparing two segments. If I was doing the sides, I would have had to do the lengths of 4 different segments, then compare these two, are those perpendicular, and then are those two. So I would have to make twice as many comparisons. Not that that would be a horrible thing, it's just extra work.